Okay, I hope I'm audible to all my students who are attending this particular lecture for the IIT-Jam economics course. In this particular lecture, I'm going to start with the discussion of the 2024 question paper, which has come up for the IIT-Jam economics entrance. Okay, you can clearly see the 2024 IIT-Jam economics question paper on your screens. So in this lecture, I'm going to start with the discussion of section A, which contains problems from question 1 to question 10. And all these questions within section A are for 1 mark each. Okay, so let's quickly start with the discussion of problems from section A in this particular lecture. So let's look at question number 1. Which one of the following is a non-parametric test? Now, clearly, it's a question which we do in the statistics module when we look at tests for conducting hypothesis. Okay. If you look at the options, first of all, students should know what is a parametric test versus what is a non-parametric test. Now, when we talk about parametric tests, they make some assumptions about the underlying distribution, whether it's a normal distribution or it's a t distribution or f distribution. When we talk about non-parametric tests, they don't speak about the underlying distribution. They don't make us any assumption about the underlying distribution. So out of these four options, chi-square test is the only test which is a non-parametric test because it does not make any assumptions about the underlying distribution, whether it's normal or not normal and so on. So my answer for this question is option A. Let me quickly come to the whiteboard, and just as a note, I can explain non-parametric tests to all students. This is in addition to the answer we have marked. I'm coming to the whiteboard on the main. I'm writing the main heading first just for completeness. We are looking at IIT Jam economics paper. This is the 2024 question paper we are discussing. And for question number 1, I'm making all students write a note. Okay, so students can write that non-parametric tests are those statistical tests that do not rely on the assumptions made about the underlying distribution. They do not rely on the assumptions being made about the underlying distribution. Okay. Parametric tests, on the other hand, I can write parametric tests, on the other hand, do make assumptions about the underlying distribution. They do make assumptions about the underlying distribution. Chi-square test is clearly a non-parametric test. Chi-square test is clearly a non-parametric test. Okay. And when do we use chi-square test, students? Recall, we use chi-square test when we have to test the hypothesis of the population variance being equal to a certain hypothesized value. We also use chi-square test when we have to when we work with categorical data, where we have categories. Okay, so we use chi-square test when point A, we have to test whether the population variance sigma square is equal to a certain hypothesized value. When we have to test whether the population variance is equal to a certain hypothesized value, okay, suppose my null hypothesis is sigma square equal to sigma naught square, where sigma naught square is a constant. Then we use the chi-square test, okay, and we also use the chi-square test when we have to assess the categorical data. So I can write on the top, if I erase the initial portion of, I hope students have all noted this down. On the top, I can write point B. We also use the chi-square test for categorical data. To assess whether the observed frequencies call them as OI, differ significantly from the expected frequencies EIs. Which is EI. Okay, so we also use chi-square test when we are working with categorical data. And in each of these cases, we are not concerned with the underlying distribution. I can write in each of these cases, we do not make any assumption. In each of these cases, we do not make any assumption about the underlying distribution. That is why the chi-square test is a non-parametric test. In the first case, guys, remember, recall from my lectures on statistical inference, we simply calculate chi-square computed value, which is n minus 1 s square over sigma naught square, where s square is the sample variance. And we reject the null hypothesis if my chi-square computed value exceeds the chi-square critical value with n minus 1 degrees of freedom. Something students are going to find in my lectures on statistical inference when you subscribe to my complete course for the Iit-Jam economics. Okay, and similarly for point B, we calculate something called chi-square computed value, which is nothing but summation OI, which is my observed frequency, minus EI, which is my expected frequency, square divided by EI. So we calculate this chi-square computed value, which is summation OI minus EI square over EI, where OI is my observed frequency, EI is my expected frequency. Okay, so OI denotes the observed frequency for category I, EI denotes the expected frequency for category I. And then again, I calculate something called the chi-square critical value. Okay, this is chi-square critical value. I can say chi-square star, which we get from the table. And then I compare them. So I reject, in this case, remember, we reject the null hypothesis. Again, I can say we reject, for case B, we reject the null hypothesis if the chi-square computed value exceeds the chi-square critical value at alpha level of significance. So I have just given a layout. Obviously, in the exam, students were just asked to tick the correct answer. But I have also given a proper explanation because students should know as to which is a parametric test, which is a non-parametric test, and what is the crucial difference between a parametric and a non-parametric test in statistics. Okay, so marking the correct answer is not enough. That is something the students can also find the answer keys and do them on your own. My job is also to explain students as to how we arrived at that answer and as to the crucial difference between parametric and non-parametric tests in this question. Okay, so hoping students have understood this. Coming back to the question paper. So my answer is chi-square test. If you look at T test, F test and Z test, they are all concerned with the underlying distribution. They all make assumptions about the underlying distribution. Okay, for example, if I talk about the Z test, we assume that the distribution is a normal distribution. If I talk about the T test, the underlying assumption is that the population variance sigma square is not given to us. And the sample size is small. We use the T test in that case. Okay. F test also assumes, because F test is also called the variance ratio test, it also assumes a normal distribution, that the distributions are normal. Okay. So these all make assumptions about, they make assumptions about the underlying distribution. They all make assumptions about the underlying distribution. Chi-square is the only test which is not concerned with the underlying distribution. So if I move forward now to question number 2, let's read question number 2. Let X and Y be two consumption bundles assumed to be non-negative. That means X and Y both are greater than or equal to 0. And they are perfectly divisible. Okay. Further, the assumptions of completeness, transitivity, reflexivity, non-satiation, continuity, and strict convexity are satisfied. Now, students who have subscribed to my complete IIT-JAM economics course, in my lectures in the intermediate microeconomics course, you're going to find what is meant by the completeness assumption, transitivity assumption, reflexivity assumption, non-satiation, continuity, and strict convexity. Please check out my lectures on consumer preferences within my intermediate microeconomics course, okay, for complete detailed discussion of all these assumptions. Okay, so which of these following statements is not correct? There is one of these statements which is not correct. Either X is preferred to Y or Y is preferred to X or both. If you look at this, this is the completeness assumption. Completeness assumption simply states that given any two consumption bundles, either X will be preferred to Y or Y will be preferred to X or both. So this is not my answer because it's correct. We need to find the statement which is not correct. Statement 1 is correct. Statement A is correct. Let's look at statement B. Y is preferred to X if Y contains more of at least one good and no less of the other. It is non-satiation assumption. So again, it's correct, but we have to find the statement which is not correct. So this is not my answer. X is indifferent to itself. If you see, this is the correct answer. X is not indifferent to itself. This is wrong. If you look at the reflexivity assumption, according to reflexivity, any bundle X is weakly preferred to itself. And when I say weakly, it also includes indifferent. So I can say reflexivity assumption is violated. Reflexivity assumption is violated. Let me quickly come to the whiteboard also to explain this. Question 2. Recall from my lectures on consumer preferences. The course I'm talking about is my intermediate microeconomics part 1 course. Students can have access to this course when you subscribe to the complete IIT-JAM economics course, intermediate microeconomics part 1. Okay. We can talk about the reflexivity. A bundle is at least as good as itself. A bundle is at least as good as itself. This is the reflexivity assumption. Reflexivity assumption. So I can say that a bundle X is therefore weakly preferred to itself. So which also implies that X is indifferent to itself, because weakly also includes the indifference part, right? Weakly also includes this indifference part. So X is, I can write, indifferent to itself. Remember, at least as good as also includes the indifference. That means if coming back to the question paper, this is the statement which is not correct. That means this is my answer, because we had to choose the statement which is not correct. Option C is my answer, because this statement is not correct. Okay. If you look at option D, that's correct. For X or Y, its better set is strictly convex. We have already shown this, that if you take any set X, its better set will always be strictly convex. Okay. So remember, if I quickly draw a diagram, this is good X, this is good Y. This is my indifference curve, which shows combinations of good X and good Y, which give equal satisfaction to the consumer. Okay. If I choose any bundle of X1 or Y1, what is my strictly better set? I have done this again in my lectures on consumer preferences. This is my strictly better set. Because of monotonicity assumption, the shaded area contains more of both the goods compared to X1, Y1. This is the strictly preferred set. I can say this is strictly preferred set, which we denote like this. And this is the convex set. If I take any 2 points in this set, in the shaded area, if I join them, the line segment lies within the set. Take any 2 points. Take a point here, take a point here. Join them. The whole line segment lies within the set. So it's a convex. That means that this is not the answer. I can write this is not the answer. Because it's true, we have to find the statement is incorrect. My answer is options. If I scroll down to the next question, question number 3. Consider a production function of the following form: y is equal to a log L plus 1 minus a log k. A lies between 0 and 1 strictly, and a is not equal to 0.5. Y denotes output, L denotes labor, K denotes capital. We need to find the absolute value of elasticity of substitution. Again, I have covered all this in my lectures in intermediate microeconomics course. Elasticity of substitution simply captures how the K by L ratio changes when we move along the isoquant. That means when RTS, when the slope of the isoquant changes, when rate of technical substitution changes, how K by L will change. So if I quickly come to the whiteboard to solve this, so we are given that y is equal to a times log L plus 1 minus a times log k. We are given that a lies between 0 and 1. We are given that a is not equal to 0.5. Okay. And we know that y denotes output, L denotes labor, and k denotes capital. I am just writing it for clarity. So I can write this as follows. I can write it as, using properties of logs, a log L, I can write as log L to the power a. And 1 minus a log k, I can write as log k to the power 1 minus a, using properties of logs. Properties of logs. And then I can write this as log of L to the power A, K to the power 1 minus A. Again, we are doing this because of properties of logs. Okay, so you can see that it's a monotonic transformation of a Cobb-Douglas production function. So you can clearly see this is a monotonic transformation. It's a monotonic transformation of a Cobb-Douglas production function. This is a monotonic transformation of a Cobb-Douglas production function. Okay, the formula for elasticity of substitution, we all have covered this in the intermediate microeconomics course. Elasticity of substitution denoted by sigma is nothing but dk by L over drts times rts over k by L. Let's calculate the RTS. Rate of technical substitution is nothing but MPL over MPK in absolute terms. MPL is del Y over del L. MPK is del Y over del K. Del Y by del L, if I differentiate the production function with respect to L, I get 1 over L alpha K 1 minus, it's not alpha, let me correct myself guys, it's A. I am actually more habitual to using alpha, that is why I wrote alpha. So the derivative del Y by del L will be 1 over L to the power A, K to the power 1 minus A times the derivative of L to the power A is ALA minus 1. K to the power 1 minus A is as it is because we are differentiating partially. Whole divided by del Y by del K will be 1 over L to the power A, K to the power 1 minus A times. Internally, the derivative of L to the power A, K to the power 1 minus A with respect to K will be 1 minus A, L A, K 1 minus A minus 1, which is minus A. Students should be good with partial derivatives to crack this question. Now this cancels with this. So if I write on the top, if I erase all this off, I can write that the rate of technical substitution RTS comes out as AL to the power A minus 1, K to the power 1 minus A over 1 minus A times L to the power A, K to the power minus A, which I can write as A over 1 minus A times K, the base is the same, so I can subtract the powers on the top, 1 minus A minus of minus A over, I can take L in the bottom, so it's A minus A minus 1. I'm using power rules. So RTS is going to be A over 1 minus A times K to the power 1 minus A plus A over L to the power A minus A plus 1. Minus A plus A and minus A cancel out. I get my RTS as A over 1 minus A times K by L. So now what will dRTS by dK by L? I am erasing all this off. Let the formula still remain on the screen. This is the formula for sigma, remember? This is my formula for elasticity of substitution. So if I do dRTS over dK by L, what am I doing? I am differentiating RTS with respect to K by L. I just get A over 1 minus A. If I differentiate this with respect to this, don't I get this? So now I can just write what will dK by L by dRTS be? If I take the reciprocal, what do I get? If dRTS over dK by L is A over 1 minus A, then dK by L by dRTS will be 1 minus A over A. Now it's the time to plug everything in this formula. So if I erase this initial portion off, I can write that sigma, which is my elasticity of substitution, is going to be dK by L by dRTS is 1 minus A over A times RTS. What did RTS come out as? Students can recall that RTS was A over 1 minus A. RTS was A over 1 minus A times K by L divided by K by L. Divided by this K by L means times L by L. or if students haven't understood this, this whole is divided by K by L. This K by L at the bottom in yellow color. When I divide by K by L, I can now erase this and I can write times L by K. Times L by K. L and L cancel out, K and K cancel out, 1 minus A, 1 minus A cancel out, A and A cancel out, my answer is 1. That means elasticity of substitution is exactly equal to 1. So if I come back to the paper, we can mark the correct answer, it is 1. This is my answer for this question. And we all know that for a Cobb-Douglas production function, elasticity of substitution is anyways equal to 1. So in the exam, you don't need to do the math. If you know already that for a Cobb-Douglas function, elasticity is equal to 1, because after all, you need to mark the correct answer. You don't need to show how you got that answer. My job is to show all my students how we got the answer. But if we know the results from before, we don't need to waste time in working out the answer. If we know that for a Cobb-Douglas function, elasticity of substitution will always be 1, it will always remain 1. All students have to figure out was that this is a Cobb-Douglas, this is the monotonic transformation of a Cobb-Douglas production function. So hoping students have understood this. Okay. And then the last question I intend to do for today, question number 4. Consider a closed economy with the consumption function C, which is 2 plus 0.5y. Y denotes income. Government expenditure is 3 and investment function is 4 minus 0.5 R. R is the interest rate. We need to find the slope of the IS curve. Now, this is something I've covered up in both my introductory macroeconomics as well as intermediate macroeconomics course. Students can subscribe to my lectures on Keynesian economy and ISLM. Very important topic from Iit-Jam economics point of view. Okay, the IS curve, simply also called the income spending curve or the income savings curve, gives you combinations of output and interest rates such that the goods market is in equilibrium. Usually we call it as the income savings curve. Sometimes some of the books also call it as the income spending curve, but usually it's the income savings curve. Or I can say investment savings curve. Okay, so investment saving, IS denotes here the investment savings curve. It shows combinations of output and interest rates such that the goods market is in equilibrium. Okay, how do we find the slope of it? If I quickly come to the whiteboard, this is question number 4. I'm just writing what is given. We are given that the consumption function is 2 plus 0.5 y, and we are given that y here denotes income, c here denotes consumption. Government expenditure is 3. It's exogenously determined. It's given to us as a constant. Investment is 4 minus 0.5 R. Capital I denotes investment, just for clarity, and R here denotes the interest rate. Okay, when is the goods market in equilibrium? We all know the goods market is in equilibrium when we have the national income identity satisfying. Y is equal to C plus I plus G. Obviously, we don't have net exports given to us. We assume a closed economy. So Y is equal to C is just plug in the value 2 plus 0.5 Y. Investment is 4 minus 0.5 R. Government expenditure is 3. Bring 0.5 Y to this side to get all the Y terms together. Then we have 2 plus 4, 6 plus 3, 9 minus 0.5 R. So if I solve this, y minus 0.5 y is just 0.5 y equals 9 minus 0.5 r. So my y comes out as 9 minus 0.5 r over 0.5, which implies y is equal to 9 over 0.5 minus 0.5 r over 0.5. This cancels out. I get y as 18. 9 over 0.5 is 18 minus r. And if you look at the slope of this, slope is dy over dr, which is minus 1. It is dy over dr, which is minus 1. Okay, so if you do dr over dy, that will come out. If you do dr over dy, that also comes out as -1. Assuming that we are measuring y on the horizontal axis and r on the vertical axis, I can also write it like this. Just for clarity, if I erase this particular part on the top, from this equation, I can also write that r is equal to 18 minus 1. So if I do dr over dy, because when we plot the IS curve, students, remember, we have y on the horizontal axis, we have interest rate, and the IS curve is usually downward sloping. So the slope is nothing but dy over dx. On the y-axis, we are measuring r. On the x-axis, we are measuring income, which is y. So my slope of the is will actually be dr over dy. If I differentiate r with respect to y, my answer is minus. So if I come back to the question paper, the answer for this question, the slope of the is curve will be -1. This is the correct answer for this. Okay, so I stop in this particular lecture. The objective was to solve the first 4 problems which have come up in the Iit-Jam 2024 question paper. Okay, in the next lecture, I'm going to start with the discussion of question number 5. So I stop in this lecture. I hope students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.